Hi class, it's Bill back with another video in week 10 of Java 2 class. We started in this week talking about stacks and queues. We talked about some of the basics of them and what they represent. We did a little bit more in-depth exploration on stacks in the last video, and in this one we are jumping into queues and looking at how those are implemented, the ideas behind them, and a little bit about how you might code these things. So we talked about stacks. Let's go on to queues. Here we go. So queues are, again, an ordered collection. They can be implemented with something very simple like a linked list. And in these are going to be first in, first out. So these are FIFO, whereas stacks are LIFO. Again, you may have learned the acronym switched, but this is the opposite, right? First in, first out. Now, this is a really easy analogy because we have queues everywhere. We stand in lines. In fact, the British would say, queue up, right? If you are at the post office or you're at wherever you are, queue up. And so queues are everywhere. And we know that this person is the first in line. This person is going to get served first. New people come in back here, right? New folks are going to come in at the end of the line back here, but they're served from the front of the line. So the first one in is the first served. First come, first served. Last come, last served, right? So we know that that's how queues work, but notice with a queue, you're working at opposite ends, where with the stack, you're always working at the same end. Now, when you're working with queues, we don't have the specialized names like push and pop like we do with stacks. Typically, you're going to see just add and remove or something like that. But sometimes in some applications or some context, you'll see the terms NQ and DQ, which I kind of like. There's something that rings nice about that, where you're putting someone into the queue and then we're taking them out of the queue by DQing them. So I like those words a lot. So how are those used? If you wanted to make a queue in Java, how would you do that? Well, one of the things you can do is use the queue interface. Notice that's not a class, it's an interface. So very typically, you're going to see sample code like this if you look at the internet for examples. You're going to say, I want to make a strongly typed generic queue, right? This is a queue interface that requires a type parameter. I'm going to make a queue of integer wrapper typed items, but I'm binding it to a new linked list, and the new linked list is again of that strongly typed integer type. So one question for you is, why do they use queue over here? Why don't they just make a linked list queue equal to new linked list? So why is this data type different than this data type? Think a minute. Pause if you need to. The answer is that, remember, when you have a binding, when you have this binding of this variable q to this particular actual list in memory, linked list in memory, remember that the static type over here, the static type of the binding, is going to determine the visibility of what this sees in terms of methods. So when you say Q dot, if you have an IDE that does autocomplete, which probably a lot of you do, you're going to see Q dot only brings up Q integers, or methods. So you will see, and my analogy, if you were with me for looking at inheritance, is that these are like goggles. You're looking through Q goggles, and Q goggles can only see Q-ish things. Right? They can't see anything that's beyond that that might have been, that has to do with the thing on the right-hand side. So when you go to access the variable q, in this case, you're going to see exactly these methods, right? All you're going to see is those. Even though linked list might have more, we are trying to be proper queue coders, and a queue has more limited methods. Does that make sense? So sometimes an interface over here helps us to limit ourselves to doing things that we only want to do based on that static type. Cool. So what kind of methods are here? Well, you need to be able to add, right? Somebody needs to be enqueued. In this case, you can also peek, right? You can peek at the first element. Now, there's several of these things that are kind of the same. Like there must be some context in which these words make sense, because you have this thing element, but that does the same thing as peek. And you have this thing add, and that does the same thing as offer. So both of these are pretty much the same. So there's a way to add. There's a way to remove, which actually removes it, and then there's a way to peek to see what's the next person in line, right? So there's a whole bunch of duplicated in terms of different terminology, but they really do the basic stuff. You can put data into the queue, put objects into the queue. You can peek at the object to see what's next, and you can remove them. That's it, right? Notice there's not even an idea of a size. There's not even a way to know whether it's empty because it's just going to return null, all right? You're going to get null. So the concepts here are simple, and the code or the methods that you can access are very simple for queues as well. So where are these used in computer science? Well, tons of places. When you have print jobs, for instance, there is a print queue, right? You have a printer, it needs to queue up all the jobs that you're sending and print them one at a time. Obviously, that needs a queue. If you have a system that is multi-core or a larger system, if you think of big server systems, there's a lot of different jobs that need to be run. The jobs themselves have to be queued up. Network packets are going to be queued up. They've got to be sent in a really specific order. And of course, if you think of wanting to model things like a line of customers, a line of clients, again, if you're in class with me, sometimes we do a project on a tech service call queue where there's techs and there's customers, and they need to be queued up and paired together, etc. So queues are everywhere. So no doubt you'll run into those somewhere somehow. Now, what kinds of operations? Again, from an academic standpoint, if you look in your textbooks or you look at online and see the sort of head scratcher, how do I do this kind of problems, these tend to be like problems of I have a queue and I want to make it into a stack and I want to keep the order the same. I want to add up all the values that are in an item, or I want to remove a specific item from the thing, but otherwise I want the thing to remain the same as it was. So how do I do that, and how is it different with a stack and a queue? I want to compare two things and see if they're similar. So in all of these are great brain exercises to make you think with a limited set of resources, a limited set of methods, how am I going to accomplish those particular tasks? So some of these are very tricky because you don't want to lose data, you don't want to change the order, etc. And the end of our chapter certainly has a few of those good exercises if you want to practice a bit. So that brings us to the end of our queue discussion. Again, we don't really need to look at code because you've seen linked lists. Go back and watch those videos if you'd like. And you can very easily implement these with a simple linked list. And I encourage you to maybe play with that and make your linked list code a little bit dumber, right? Take out some of the stuff that you have in a linked list and sort of pare it down to the things that you would only do with a stack or a queue, and play with that if you want to get some experience. So thanks for watching these videos. We will return with some other videos in the series, and thanks for watching.